of environmental rationale that, you're not breaking the environment. The second is that you're not taking away electricity and like other resources from other people, right? Like I think just today I saw a story about like Iran wanting to shut down some Bitcoin mining because it was just grabbing up so much electricity that it was, outbidding the nearby towns, and they just didn't have enough. And then there is like Chia, the one that's doing proof of like hard disk mining, basically is just like grabbing up so many hard disks that there's a shortage, right? So that's the second reason. And then the third, more selfish reason is that because participating in consensus does not require so much energy expenditure, you don't need to pay people as much to participate, right? So like Bitcoin and Ethereum, they both issue somewhere around 4% of the total supply every year right now to miners. So Ethereum is about 4.7 million Ether, and the current supply is about 115 million. But with proof of stake, like we expect it'll be somewhere between 500,000 and 1 million per year. So that means the supply doesn't have to increase so quickly. So
one of the pros that that people sort of argue for the proof of work is that it is secure because it's much more difficult to sort of, as you've highlighted, it's difficult to participate. What are your thoughts about the security of the proof of stake mechanism? Is there ways to make it secure?
So I think proof of stake is very secure because in order to be able to attack the system, you need to have like basically as much stake as the rest of the network, right? So that means like right now, for example, we have 5 million ETH staking. So you have to come up with 5 million ETH and then join the network. And then the other, so 5 million ETH is a lot, right? It's like, how much is it now? Like $15 billion. So that's actually more than I believe the cost of attacking the Bitcoin network. And then the second thing is that recovering from attacks is much easier in proof of stake than in proof of work, right? Because in proof of stake, you have, like, first of all, we have, for many kinds of attacks that you do against this network, we have this concept of like automatic slashing, right? Which basically means that in order to like revert a finalized block. So if there's one block that's like accepted by the network and you try to convince the network to kind of revert that block and accept a different block, in order to make that kind of attack, you basically have to have your validator, like a big portion of your validators, sign two conflicting messages. And this is something that, like, once these messages are on the network, like, you can go and prove, like, look, these people did it. And so we have this feature in the protocol called slashing, where you basically take all these people who provably misbehaved and you burn their coins, right? And you don't burn anyone else's coins. Now, there are other cases, like, for example, if instead of reverting blocks, the attack just tries to censor everyone, right? Then what you do, everyone who got censored would just like basically create the minority chain, and then the community would basically have to do a soft fork, right? They would just have to say like, look, this chain is clearly attacking us. This chain is the one not attacking us. And so we're going to join this chain. And then what happens is that on that new chain, the attackers also lose a lot of coins. Right.
Yeah.
So the difference between proof of stake and proof of work is that in a proof of stake system, like, you can identify specific participants and you can say, these, and like, this isn't like, a human going in and saying, I don't like you, I don't like you, I don't like you. This is like automated, right? You can.
So the slashing process is automated.
Yes.
Is there ways it can go wrong? So that's a painful process where the coins are burned.
It is painful. Yes. I think, the one big unknown, of course, is like, if an attack actually happens, and like if an attack happens that requires the community to actually choose one of these minority forks, then like, what would the community actually successfully coordinating on this look like, right? Like it's like, we can talk about it and we can, write like science fiction novels about it, but like until it's happened, you don't really know the details of like what it looks like and how difficult it is.
What are the channels of communication for the community? If you can enlighten me a little bit, like where, in many ways in the political realm, Twitter is often used as a way to kind of have these emergent phenomena of large groups of people coming to a consensus about a particular idea. And then there's battle for consensus. What's in the Ethereum community, what are the sources of natural language-based communication that have an emergent belief structure that you would say? Or is it all through money? Is it all through trading that the communication happens?
There's definitely talking as well. I mean, like we have to agree on protocol changes somehow, right? Like there's Twitter, there's Reddit, there's GitHub, there's all of the various Ethereum forums, Ethereum magicians, Ethereum research. There's just in-person communication. Then there's just kind of like the hidden web of everyone talking to everyone on Telegram or Signal. So it's like some of everything, right? But I think like the thing to emphasize around like, can you actually come to consensus on, whether or not to fork the chain because the attacker is censoring everyone, just for example, is like, everyone who's running a node is going to see almost the same thing, right? Like they're going to be off by a few seconds, and like maybe they'll be off by a few minutes. They'll disagree by a few minutes, but like if it's a serious attack, people are going to know, right? It's not like one of those things where we're trying to agree on like, I don't know, did Epstein kill himself, or like some random political fact where like in reality no one knows a single thing about what's actually going on, and they're all speculating. Like it is much more visible, right? So we do have that, but at the same time, I'm happy to admit that like these are fairly untested mechanisms, but like at the same time, they're also untested mechanisms in proof of work, right? And like in proof of work, it's even harder because in proof of work, you don't have the ability to like identify and say like, I'm going to, these miners attacked, and so we're not going to let these miners in, these miners did not attack, so we're going to keep them in. Like you have to pretty much, either take out none of the miners, or you do a fork that changes the proof of work algorithm, which takes out all of the miners, right? So the economics of like recovering from attacks in proof of work, at least to me, actually do seem like more unfavorable. But I'm sure the proof of work people you talk to will give very different and contradictory opinions, and that's totally fine and amazing.
Some people describe MEV, miner extractable value, as an existential risk to Ethereum. What is MEV? How important is it to solve an MEV? If it's important, what ideas do you have?
Sure. How about after this one, we'll also talk about sharding, because it's amazing and it's part of it.
We'll return back to sharding, and we'll return to the big picture of the scaling problem, as you mentioned.
I love this conversation. Depth first search instead of breadth first. So basically, okay, MEV, miner extractable value. It is not different in proof of work and proof of stake, right? So like if you want to call it, block proposer extractable value, like it sounds less sexy, but we can call it BPEV instead of MEV. Who cares? But
this is a problem in both proof of work and proof of stake.
Yes. So the basic idea is that if you have the ability to choose which transactions go into a block and in what order, then you have the ability to like take advantage of that position for economic gain in a lot more ways than just collecting transaction fees, right? Like for example, there's decentralized exchanges on chain like Uniswap. And like let's say the price of ETH versus USDC was 2,700 the previous block, but then there was a bit of a market drop and now it's 2,680, where you can go on Uniswap and you can just like gobble up the entire part of the automated order book that's like between 2,700 and 2,680, right? And then at the same time you like run a bot and you buy some ETH back at 2,680 and you've just like made about $10 of profit, right? So $10 times whatever the depth is, right? So there's lots of little things like that. There's also things that involve like front running other people's transactions. So one example of this would be that if someone sends a transaction that says, like, I don't know, buy me 5 ETH for whatever price that you can get, but with a maximum of let's say $15,000, then you can go and like you can put a transaction right in front of that transaction, and you can like buy up that ETH first, and then you resell it to him at $15,000 minus one. So and then
you get to make a little bit of money that way.
Exactly. So there's a lot of these different like arbitrage, front running, back running, these different tricks that allow block proposers to get
some percentage on top, like overhead.
Exactly. Okay, and the reason why this is a challenge is because first of all, it sometimes degrades user experience because users get less favorable trades. But there are sometimes ways to like mitigate that for applications. Sometimes it's not that bad. But like the bigger risk that I think some people consider more existential is that there's just much more economies of scale in figuring out how to extract all this revenue. right? Because if you're just collecting transaction fees, there aren't really economies of scale. There aren't really benefits to centralizing, right? Because it's a very simple formula. You just like grab up the transactions that pay you the most. But with MEV, there's all these sophisticated algorithms, and if you have lots of money, then you can hire really smart people to make amazing algorithms, and then you can use the other half of your money to get a lot of mining power or a lot of stake, and you get a lot of opportunities to use your even better algorithms. So there's this risk that, like, as a result of this, mining is basically, or even validating proof of stake is going to centralize. So I think the ecosystem's best reply to this sort of risk, and it's the direction where projects like Flashbots are going already, is if you can't eliminate the centralization, then you try to firewall it, right? And the way that you firewall it is you basically say, we're going to try to deliberately create a marketplace where people can just do the complicated work of creating what are called bundles, like bundles of transactions that like are very profitable, right? And then at the other side of the market, you just have like block proposals reminders that are just dumb nodes, and they go and ask the what are called searchers, the bundle creators, and they just ask like, hey, like how much can you give me if I put in your bundle? And then they just take the highest offer, right? So you sort of separate out the task, and you have the easy part, and then you have the hard part, and you have like this special class of actor called a searcher that does the hard part, and then the easy part, the people doing the easy part, which is just miners and validators, they kind of just talk to all the different people doing the searching, and they just accept the highest bidder, right? So, and this is also just like an interesting example of like economic design philosophy, right? Like sometimes you can't just like make centralization go away. Sometimes it's inevitable, but at least you can try to kind of contain it. You can direct it, or you can even sort of firewall it away from core consensus, the parts that really do need to be decentralized. So,
but you don't see it as an existential. Okay, let's talk about the other really, really fascinating part of the future of Ethereum. Let's not call it Ethereum 2.0, but the future of Ethereum that also may require a hard fork. I don't know. You can correct me on this. Is, well, broadly, ideas for scaling.
Yes.
And more specifically, sort of layer 2 or layer 1 and 2 intersection ideas of how to achieve scaling. And at the core of that is the idea of sharding. So first, what is sharding?
Okay. So there's two major paradigms for scaling blockchains, right? As you said, layer 1 and layer 2. And layer 1 basically means make the blockchain itself like capable of processing more transactions by having some mechanism by which it can do that, despite the fact that there's a limit to the capacity of each participant in the blockchain. And then layer 2 says, well, we're going to keep the blockchain as is, but we're going to create clever protocols that sit on top of the blockchain that still use the blockchain and then still kind of inherit things like the security guarantees of a blockchain. But at the same time, a lot of things are done off-chain, and so you get more scalability that way. So in Ethereum, the most popular paradigm for layer 2 is rollups, and the most popular paradigm for layer 1 is sharding.
So one way to achieve layer 1 scaling is to increase the block size.
Yes.
Hence the block size wars, quote unquote. And you actually tweeted something about people are saying that Vitalik changed his mind about he went from being a small.
No, it went from being big to small.
Big to small, and but you said I've been a medium blocker all along. So maybe you can also comment on the very basic aspect before we even get to sharding of where you stand on this block size debate.
Sure. So the way that I think about the trade-off is I think about it as a trade-off between making it easy to write to the blockchain and making it easy to read the blockchain. Right. So when I say read, I just mean, have a node and actually verify it and make sure that it's correct and all of those things. And then by write, I mean send transactions. So I think for decentralization, it's important for both of these tasks to be accessible. And I think that they're like about equally important, right? If you have a chain that's too expensive to read, then everyone will just trust a few people to read for them. And then those people can change the rules without anyone else's permission. But if, on the other hand, it becomes really expensive to write, then everyone will move on to basically second layer systems that are incredibly centralized. And that takes away from, decentralization and self-sovereignty as well. So this has been my viewpoints like pretty much the whole time, right? It's that like, you need this balance, and going in one direction or the other direction is very unhealthy. In the Bitcoin case, basically what happened was that Bitcoin originally, like at the very beginning, it didn't really have a block size. It just had an accidental block size of 32 or a block size limit of 32 megabytes, because that just happens to be the limit of the peer-to-peer messages. But then,
interesting. I didn't even know that part.
Yeah, but then Satoshi back in 2010 was worried that even 32 megabyte blocks would be too hard to process, so he put the limit down to 1 megabyte. And I think
by put, you mean sneaked in there?
Yeah, just like made an update to the Bitcoin software that made blocks bigger than one. I think it's 1 million bytes invalid. And I think the impression that most people had at the time is that, this is just a temporary safety measure, and over time, as we become more confident in the software, that limit would be like raised somewhat. But back then, when the actual usage of the blockchain started going up, and then it started going up first to 100 kilobytes per block, then to 250 kilobytes per block, then to 500 kilobytes per block, there started kind of coming out of the woodworks this opinion that like, no, that limit should just not be increased. And then there are all of these attempts at compromising, right? First there was like a proposal for 20 megabyte blocks. Then there was the 248 proposal, which is a bit ironic, because the 248 proposal started off being like a small block negotiating position. But then when the big block people came back and said like, hey, aren't we going to do this? They're like, oh, no, we don't want the block size increases anymore. So there were these two different positions, right? The small blockers, I think they valued 1 megabyte blocks for two reasons. One is that they just like really, really believe in the importance of being able to read the chain. But two is that a lot of them really believe in maintaining this norm of never hard forking, right? So the difference between a hard fork and a soft fork is basically that in a soft fork, blocks that were any block that's valid under the new rules was still valid under the old rules. So if you have a client that verifies according to the old rules, then you'll still be able to accept the chain that follows the new rules. Whereas with a hard fork, like, you have to update your code in order to stay on the chain. And look, they have this belief that, soft forks are kind of either less coercive than hard forks, which, by the way, I completely disagree with. I actually think soft forks are more coercive, because like basically they force everyone who disagrees to sort of go along by default. Or they have this opinion that there's like, it's more difficult to